So now we're going to take a look at dividing complex numbers. Now, by dividing complex numbers, we really mean rationalize the denominator, because we saw when we had square roots on the bottom a couple of sections ago that we had to multiply it to the top. Well, technically that's what you have here. This is really a square root of a -1, so we can't have that square root on the bottom. So when we say dividing complex numbers, it would really, another good way of saying it would be rationalize the denominator. So to do that, what we need to do is, just like when we had square roots on the bottom, we multiply the top and bottom by the conjugate of the bottom. So conjugate, I'll write that up here. So the conjugate for 5 plus 2i is 5 minus 2i. Now again, the nice thing about multiplying by a conjugate is you don't have to do the whole FOIL process. You just do the F and L. There's no OI. In other words, I just multiply my first, the 5 times the 5, which gives me 25. And then I get my negative 2i times my positive 2i, which should give me negative 4i squared. Now, that's the bottom. The top, I have to do the full FOIL process. So I have to multiply my first, which will give me 40. To multiply my outers, which will give me negative 16i. I multiply my inners, which will give me 45i. And finally, I multiply my last, which would be 9i times the negative 2i, and that should give me negative 18i squared. Okay. Now I need to simplify. First, let's start on the bottom. On the bottom, we see that we have 4i squared. The I squared is really negative 1. So negative 4 times negative 1 actually turns into positive 4. So really this is 25 plus 4 on the bottom. And of course we need to further simplify that to be 29. On the top, the 40 is by itself, but we're going to add to it because this is I squared. That's really just negative 18 times negative 1. So that turns into positive 18. So we get 18 plus 40, and that should give us 58. We'll write right here. And then we should go ahead and take our negative 16 and positive 45. So just 45 minus 16. And we should end up with positive 29i. So I'll just rewrite it over here. We got 58 plus 29i. Now, I actually need to rewrite it in a better place so that we can see 58 plus 29i over 29 actually needs to reduce. This is a Dorito problem. So, and by Dorito problem I mean triangle problem. So we can have a, let's change it to salsa verde Dorito problem. In other words, it's just a green triangle. But salsa verde Dorito problem, because all three of these, the 58, the 29i, and the 29, all have a 29 in common, which means that I need to divide them all by 29. And that should result in 2 plus 1i over 1, but you don't need to put it over 1, because 58 divided by 29 is 2, 29 divided by 29 is 1, 29 divided by 29 is 1. So really it's 2 plus I over 1, and that's why we just write 2 plus I. Okay, so that's a Dorito problem. You may have heard it called a triangle problem. I just try to put a little spin on it. So let's try one more problem, dividing complex numbers. Again, dividing complex numbers really means rationalize the denominator. This time I just wanted to show you one where it's just a number. It could be an I, it could be a 2i, whatever it is. This time we just have to multiply top and bottom by the I. Okay, let's make it back to an I. Maybe I'll do it again with 2i. But multiply top and bottom by just the I. Okay? And when that happens on the bottom, this turns into I squared, which should turn into a negative 1. Then on the top I need to put parentheses and distribute, and this should turn into I, because 1 times I is I, and then plus I squared. And that turns into a negative 1. So I should rewrite it so that the real part comes first, negative 1 plus I. Okay? So this was almost the answer. The only thing is here, it's kind of a triangle or Dorito problem, but really, because there's a negative 1 on the bottom, you just want to go ahead and divide negative 1 by the negative 1, and the positive I divided by negative 1. In other words, we could rewrite this to be positive 1 minus an I. That would be a better answer than leaving a negative on the bottom. Okay? So this is this particular example. Now I'm going to show you again if it had a 2, okay, or an actual number in there. So let me erase. And let's say that the 2 was really there. And all I do is I just multiply top and bottom 2I now. Okay, the number doesn't make any difference. The bottom now, though, it does multiply to be 4I. In fact, actually, I didn't have to multiply the 2 as well on the top and the bottom. That would actually make it. Let's back up. So again, if there was a 2 originally in the problem, if I'm just adding it in there, I don't actually multiply top and bottom by 2. I could, but it's easier just to multiply just by the I top and bottom, and this would give me 2I times I, which would give me 2I squared. Okay? And so then that would turn the bottom back into negative 2, because it'd be 2 times negative 1. Now, had I messed up like I was doing, which again is not really wrong, but if I multiplied the 2 in there, all that would do is cause this to be a 4 instead of a 2. But it's not necessary, so that's why I was erasing and trying it again. So I just wanted to remind you or show you that if there was a number in front, you still just multiply the I to the top and the bottom. And on the top, I would distribute, and I get the same answer as I did before, which would be I minus I squared, which gives you negative 1 plus I. Okay. Now even here, with this problem, it's not very good to leave a negative on the bottom if at all possible. Really, you should divide both of these numbers by that negative, and a better answer, granted this is a correct answer, a better answer would be positive 1 minus I over positive 2. It's the same answer, but what I'm doing is I'm changing the signs all by a negative, and that way the bottom number is positive rather than negative.